We have a chapter which name is Laws of Motion. I will share all information that will be important from this lecture. Name is written over here, which is Laws of Motion. In this, you will understand Newton's law, all all three laws of Newton. Uh, our focus will be on the motion. We will start from rest and then we will see force acting on the object. Then object will be moving. So a lot of things will be covered in this lecture. So you have seen that this is a name of a lecture over here. This is my name is written over here. It's me, and background is showing uh, background is showing discussion of this lecture. Clear? So let's start. Here we are starting with this slide. uh, Introduction of a force. Introduction of a force. Force is just pull or push. It is a lifting or moving object, uh, and uh, just upward force, downward force is all these are force. A force is just a push or pull. A force is applied on object, then that object will change itself position. This is what happens, and it will happen when we will apply force on object. Object can be moving, object can be in a rest, object can be in motion. In any situation we can apply force, but state of motion will be something else after applying force on that. For example, a moving object is coming. A object is coming to you. Now you have to apply force. Then two things that you can do. First, by applying just force, you can stop a object which is coming, and second, you can accelerate that object. You can increase a speed of a moving object which is coming to you. These two things can happen by you, and apart from this, more things can happen. But right now I am assuming that yes, these two things can happen. Here a force is just a push or pull upon an object resulting from its interaction with another object. Even I didn't understand from this sentence, but just understand a force is just push or pull. It can be lifting, okay, it can be moving a object. By applying force we can change place of a object. By applying force we can change the shape of a object. If object is flexible, then flexible solid shape. Clear? By applying force we can increase the speed of moving object. By applying force we can stop a moving object. By applying force we can decrease the speed of a moving object. All this can happen by us when we will apply force. So in this lecture, force will be external. It will be external force. In this lecture you will realize it can change the state of motion of an object. It can change the shape of an object, as we know. Now here in this figure you can see she is pushing this object, he is pulling this arrow, and he has a magnet, and here a person is sitting under the tree, and apple is falling towards the earth. Here this children is riding the cycle, and here this object is blocking this object. This type of a force is called friction force. Let's move. Our focus is not on this in this lecture. It is just a revision, otherwise you can say it is just a memorize that yes, connection of a force is with Newton's laws. Now we have a types of a force. Balanced force, types of a force. Then we have unbalanced force. It is a something new for us. Balanced force, from this word you can understand meaning of this balanced force. Forces in both sides in LHS as well as in RHS, amount of newtons are same. In LHS, amount of newtons, let's say amount of newtons in the LHS are 18, and in the RHS side amount of newton will be same, 18. Okay, this is meaning of a balanced force. Here you can see this is 4% and this 4%. This is 4% each. In this each 4% is applying, let's assume how much, 120 newtons. Same here in this side, each 4% is applying 120 newtons in this side. That's why nothing will happen here. This will not move this side and this person will not move this side, because of forces in both sides are same. That's why. Do not change the state of motion. Yes, of course, if forces are same in both sides, then nothing, motion will not happen, nothing will move. In the case of unbalanced force, one side will move. I would say both sides will move. But here something unique you will realize. What? Unbalanced. First of all, let's understand what would be meaning of unbalanced force. From this word you are understanding, yes, in one side there is a number which is let's say 80, 76, okay, 76 newtons. But in other side, in RHS side, number of newtons are could be more, could be less, but not 26. This is the meaning of unbalanced force. Did you understand? In both sides, number of newtons would not be equal. This is the meaning of unbalanced force. Clear? Now, when it comes to unequal forces in both sides, so of course, there will be motion of this side. Change the state of motion. Here you can see example of this is over here. Here she is applying how much? I think 6 newton, and here he is applying 10 newton. So both are pulling, not both are pushing. Okay, he is pulling, she is also pulling, but she is applying how much? She is pulling with 6 newton and he is pulling with 10 newton. So wo will come in which side? So this she will come this side. So here when she will come this side, it means she moved, isn't it? And now here he applied more newton than she applied. That's why she will come this side. So remember, in the case of pulling, in which side number of newtons are more? A side which has more newtons, so that side will be able to pull will be able to pull. Clear? But in the case of a pushing, what will happen? In the case of a pushing, it will be opposite in the case of pushing. Clear? So we have understood meaning of balanced force and balanced force as well. Next is a contact force. Next is a contact force. Contact force is just when we apply a force, then we touch, a object will touch, then that object will be able to apply force. Any object will be moved when another object will touch that object. Then this type of force will be known as contact force. Contact force applied through physical contact. Of course, when a object will touch the another object, it's a physical contact. And examples are muscular force, friction. These are contact force. Without contact, muscular force cannot happen. Friction cannot happen. Next is the non-contact forces. It acts without contact. It acts without contact. Yes, you will not be able to see contact of forces with in the case of a gravitational, magnetic, electric, static force. Yes, you will not be able, but still there would be contact, but completely not. So gravitational force, magnetic force, electrostatic. Gravitational is just anything which is coming from upward will be falling downward is a gravitational force. Magnetic force, gravitational is an attraction force, and magnetic is a repulsion or attraction. It attracts magnetic material or it repels the magnetic material. This is what happens with the magnet. Now next we have electrostatic. In this electrostatic we will have electric charges. Charges are same, then both will repel to each other. If the charges are unlike, then both will attract to each other in the case of electrostatic. Okay, so in the discussion of electrostatic, we take electric charges, but in the discussion of magnetic force, we take sign. We take a sign, south pole, north pole. And now in the case of gravitational force, we take a object which is coming from upward, will be falling downward is a gravitational force. Clear? So all these forces will be considered as a non-contact forces. We have visualized this figure as well. This figure is about balanced force, and this figure is about unbalanced force. She is applying 6 Newton only, and he is applying more Newton, 10 Newton. 4 is a more. 4 Newton is a more. That's why he is applying more Newtons. But in this case, in both sides, a number of Newtons are same. That's why this figure will be considered as a balanced force, and this figure will be considered as unbalanced force. I am moving forward. But here you can see this is also contact force. This is also contact force. This person is pulling this rope just by touching this rope. Then it became possible to pull this object. Here same here, contact of contact of she is with him. Same here, contact of this person is with this. Both contact of both is with this person. It is possible. So this type of force will be considered as a contact force. Contact, which means touching the other object, and contact, which means without touching something is happening. Now next let's start our main topic, Newton's law of motion. We are starting from first law. First law is also known as law of inertia. Inertia is just lazy. Okay, lazy. So an object will remain in its state of rest, and it can be in uniform motion. Uniform is just a speed of a moving object will be fixed, will be constant, unless acted upon by external force, unbalanced force. So remember, in our language, we can understand the first law of Newton's law, first law of Newton, just by understanding like this. A object uh, surrounding me, there are a lot of objects which are in a rest. There are a lot of objects which are in a rest. Now, all these objects will be in a rest. Remember, all these objects, whatever I can see, in front of me, there are books, there is a keyboard, there is mouse, there are a lot of devices, there are clothes. All these clothes right now are in rest. Now, anytime I can apply force on this object according to need. Then what will happen? Then this object will come into motion. But here I applied force. This force will be external. But a object which is in a rest will be in rest. It is a first law of Newton. But when I will apply external force, then that state of that object will become something else. Will be changed. Clear? Now, one more. Uniform motion. Look, a object which is moving with constant, I am saying, and that object will be moving because of a speed is fixed. That's why it happens rarely, but we will have to understand it also. So a moving object which a speed is fixed will be same. But when we will apply external force, then the state of moving object will be changed. When external force will be applied on that moving object. Clear? Okay, clear. Now let's see what will happen when we will apply force on moving object. Then what will happen? We can increase a moving object. Which was initially which a speed of moving object was fixed. We can increase a speed. Second, we can do is that we can decrease a moving object. This is what will happen. Clear? One more is that we can stop the moving object. That moving object can come into rest when we will apply external force. This was about first law. Clear? What is inertia? The tendency of an object to resist a change. Same. Whatever we understood about the first law, same it is for inertia. Inertia of rest. Let me explain about the inertia of rest, inertia of motion, inertia of direction. Inertia of rest is what? A object which is in a rest will remain in a rest. This is inertia of rest. That's it. But when it will come to external force, then a object which is in a rest will come into motion when we will apply external force. This is about inertia of rest. Now we are moving towards which is about inertia of direction. Inertia of a direction. What is it? A object which is moving constantly with the fixed speed will be moving with the same speed. With the same speed. Clear? With the same speed. Now, nobody is going to disturb the moving object. Then, then that moving object will be moving still. But you are that person who are going to disturb that moving object. Now, what will happen when you will apply force on moving object which is in motion? Same will happen that I told you in the discussion of first law of Newton. Here, moving object can come into rest, or a moving object can accelerate when we will apply external force. This is what will happen, and it is a meaning of inertia of motion. It is the meaning of inertia of motion. Clear? The object which is moving with the same speed will be moving with the same speed. But when it comes to external force, then state of moving object with the same speed will be changed. This is what will happen when external force will be applied. Okay, now what about inertia of a direction? The object which is moving with this uniform motion on the circumference of the circle. This object will be moving with the same speed. But as we know, when it will come to external force, then direction of this moving object can be changed. But before we change the direction of a moving object, this moving object will be moving in circle shape. It will be continue for 10 days, for 50 days. It can be continue. But when external force will come into picture, then direction of moving object can be something else. Clear? This was about inertia of rest, inertia of motion, inertia of direction. Now here, when a person will hit this object by using leg, then this will, after applying force on this, initially a speed of this would be more, but at the final speed of this would be less, velocity of this would be less, because hardly strike will be hardly on this object initially. Okay. Now I am moving forward. Examples, we have examples. A book on a table. Right now I have books, I have copies. It will be in rest if I do not do anything with this book. But I need to show a book this which is in front of me to you. Then it happened, this book initially was in rest, but now it is in front of you. It came here because I applied force. That's why it came here. So can we say position of this object was something else initially, but now position of this book is changed. A moving car stops when brakes are applied, and brake is external force. A moving car can stop if a brake is applied, and this happens because of due to friction. Friction is external force. This was examples of first law. Now we have a second. From the first law, you understand that force is being applied. Force, force is being applied. But in the second law, you will apply how much force is being applied on object. You will calculate force in second law of Newton. You will calculate. In first law, you will not calculate. You will say that yes, force is being applied. But when you will come in the discussion of a second law, then here you will see calculation of a force which was applied on object. Here you will calculate force. Second law, which is F is equal to m. M is the mass, F is the force, A is the acceleration. The rate of a change of momentum of an object is directly proportional to the applied unbalanced force. If a mass of a object is more, then we will apply more force. This is the meaning of this sentence. It is telling you if a mass of an object is more, then we need to apply more force. If a mass is less, then we need to apply less force. This is what is the meaning of this sentence. Force and takes place in the direction of the force. When we will apply force, then of course there would be a direction. That's why we are considering acceleration. That's why we will be taking acceleration. Acceleration takes a direction. Clear? A object is here, over here, and I can change the direction of this object. So it happened because force was applied. Then direction of this object became something else. F is equal to ma. M is momentum and A is acceleration. Where M is a mass. Okay, M is a mass and F is a force. Force is a unit of a force is N and a unit of a mass is kg. Unit of acceleration is meter per second square. Clear? Meter per second square. From this figure you can understand what is happening. From this figure. Hold on. What happened? Here I wanted to show this figure. Let me zoom this for you, and then confidently we will understand it comfortable. Here this figure is showing about Newton's second law. The force acting on a moving object. The force acting on a moving object is the product of the mass. He is applying force on this object, and as the force acting on a moving object is the product of the mass and acceleration. Here you can see acceleration is what? This he is applying force in this direction, and of course this object will travel. This object will cover distance. Now this object will cover distance. It means It means we will get distance. Initially a speed of this object would be something else, but final velocity of this object would be something else. That's why we are taking acceleration. And how much time was it taken just to cover distance from initial velocity till the final velocity? How much time? That's why we took acceleration. Here acceleration has direction. Here we will apply force, then here we will get direction. That's why we took acceleration. Again and again I am saying why we took acceleration. Okay. Now about proportional, let's understand. About the proportion. This object here is now mass of an object is less. Mass of an object is less, then of course we will apply less force. Of course we will apply less force, but in front of you mass of an object is more, then what will you do? Of course your mind would say let's apply more force, then object will move. This is what your mind would say. Clear? So mass of an object is more, then you will have to apply more force. If mass of the object is less, then you need to apply less force according to requirement. Clear? So here to find the force, we will multiply mass and with acceleration. Mass into acceleration. Mass into acceleration will give you force. To find acceleration, just force upon m. Okay, force upon a. Here you can see in this what is happening? Here mass of this object is less as compared to this, and mass of this object is more, but here he is applying less force, but here he is applying more force. This is what is happening. Can you tell me which one is more? In this which one is more applying force? So of course this is applying more force, so F2 is applying more force. And which object is more mass? So of course M2 is more mass. This object has a more mass. Okay, M2 is a more mass. Now let's move towards. We have again examples of second law of Newton. Second laws of Newton. A heavier object requires more force to accelerate. Yes, a lightly object will be required less force to accelerate. Kicking a football harder increase the acceleration. Yes, we saw a figure of this. Kicking an object will increase the acceleration. It means initially force on object will be applied more, then initially acceleration will be more, but gradually it will decrease. Now next, third law. From the third law you will understand nature of force. From the third law you will understand. From the first law you will see what that yes, force is being applied. But from the second law, you will calculate how much number of newtons are being applied on object. In the second law of Newton, you will calculate force. Clear? In the third law, you will you will what you will see action reaction nature. If you take action naturally, then you will get reaction. For every action there is an equal and opposite reaction. For equal, but reaction would be opposite. Action and reaction forces act on a different bodies. This one is one body and this is second is another body. He took action and this is a reaction. This boat will go backward. When he will go to forward, then this boat will go backward when he will apply force. Examples: a gun recoils when a bullet is fired. A swimmer pushes water backward so that a swimmer person can move forward. It happens. You can see nature of the third law. This is what happens. Clear? Next, momentum. We have defined as the product of mass and velocity. P is equal to m into v. P is momentum, m is a mass, v is a velocity. V is a velocity. Here we have mass, velocity. From this figure, what are you understanding? Can you tell? From this figure, you are understanding mass of this object is less as compared to this. A object which mass is less would accelerate more. A object which mass is more would accelerate less. Here you can see the speed is the same. The speed is the same. So here mass multiple velocity will provide momentum. Same here. This mass of this object is 100 kg and he is moving with this much velocity. And when we will multiply this, then we will get momentum. Impact. You will see impact. Clear? Here you can see before and after. Somebody is going to apply force on this object, then it will move. When it will move, then this will hit this object. Then this object will move, and this object will move backward. This object will move forward. This is what will happen when we will apply force on this object. Then it will move. Then it will hit this object. Then it will move to forward, but it will move backward. Okay. After this will move this side and this will move this side. This is the velocity and mass of this is more and mass of this is less. So here this is how we calculate momentum by just taking. This is how we will calculate momentum just by taking mass and velocity. Mass and velocity. Laws of conservation of momentum. Total momentum of two objects before and after collision remains the same provided no external forces. Yes, nothing will be changed until we apply external force. Nothing will be changed. In the case of inertia of rest, in the case of inertia of motion, nothing will be changed. But when it will come to external force, then there will be change of state of moving object, object. Yes, okay. Anything will be changed when external force will be applied. Clear? Now we have questions. We have questions. Let's answer together. Force is a pull or push. Newton's first law is called also law of inertia. Law of inertia. SI unit of force is just Newton, as we know. Momentum is defined as P is equal to M into V. When P is momentum, M is mass, V is velocity. Action and reaction force actors act on this same body, on the different bodies. Okay, as we saw, action and reaction will happen different body. Action will be on another object and reaction will be on another object. A force can change the shape of an object. It can change the state of an object. Yes. A moving object continues to move unless and upon by external force. By external. A moving object will be moving, but a external force will be applied. Then it will be. Then something change will appear. The formula for force is just F is equal to m, as we know. M is a mass and A is a acceleration. Okay, the unit of momentum is just P, not P. I don't know right now. That's why it will be for you. It is a for you. Friction is just a type of external force. It is an external force. It is. You can also say it is an opposite force. It work of a friction is to block the object which is coming oppositely. Subjective questions. This is also for you. 10 questions. So finally we have done. We are done. Okay. So let's see what did we explain here. About force we will understand. We understood about the types of, we saw types of forces. We saw balanced force. We understood unbalanced force. We explained contact force. We discussed non-contact force. Then we started, our focus was on the main topic, first law. It is also known as inertia of rest. With this we also understood inertia of motion, inertia of direction. Here all this is not mentioned, but I knew, that's why I explained with you. This was examples of first law of Newton. This is second law of, as we know. In this we calculate Newton's forces. We calculate forces which will be applied, which was applied on the object. This is an example for the second law of Newton. This is the third law of Newton. In this we understood that it provides a nature of the action and reaction. Action and reaction will be on different body. Then we understood momentum. To calculate momentum is just m into v. P is momentum, m is mass, v is velocity. Then we saw questions, which is the objective, and it is for you, which is a subjective question. That's all we saw. So finally, it is over.